Okay, today I'm going to show you how to graph angles in standard position. Here's some terminology that you're going to need to become familiar with. They have given you a diagram here. Whenever we're going to graph these angles in standard position, your initial side will always be the positive x-axis, and then your terminal side will always be your ray. All right, here's a little bit of a review of our degrees. So we start here at 0 degrees, 90, 180, 270, and then one full rotation would be 360 degrees. Here we have quadrant 1, 2, 3, and then quadrant 4. Now we can start graphing some of these. If we are going to plot 175 degrees, remember 175 degrees is not quite 180. So if we're going to do our rotation, we'd want to stop before we get to 180 degrees and then draw your ray. That's it. If we're going to do 267 degrees, that's not quite 270. We could stop right about there. Draw your ray. Done. What about negative 215 degrees? In order to plot negative 215 degrees, you might want to look up at your vocabulary again, those vocabulary words that are up there. In order to plot a negative angle, we have to go in a clockwise direction from our initial side. So all these previous ones, we were going counterclockwise because those are positive angles. Since this one's negative, we're going to be going clockwise as opposed to the counterclockwise that we did here. If we're using negative angles, that's going to be 0 degrees. This is negative 90. This is negative 180, negative 270, and then one full rotation would be negative 360 degrees. So if we're going to do negative, what are we doing? Negative 215. Going in a clockwise direction. That's a little bit beyond 180. So we'd stop right about there. Draw your ray. And we have now done negative 215 degrees. Now, if it wants us to plot a negative quadrant angle, let me just tell you what a quadrant angle is. It's an angle in standard position with terminal side on an axis. So what that means is, you know, all of these that we graphed here, that was negative, I'm sorry, that was 175, 267, negative 215. A quadrant angle just means your ray is on an axis. So this right here is a quadrant angle. This would be 90 degrees. This is a quadrant angle. This right here is another quadrant angle, 180 degrees. You know, look something like that. So it's just a ray that is on an axis. That's all it means. So if we need to do a negative quadrant angle, well, let's remember that we have to go in a clockwise direction to do negative, and we could stop there. Your ray just needs to be on an axis. Let's go to page 2. Okay, coterminal angles. Those are angles that start and stop at the exact same place. And guys, you can have an infinite amount, and they're really pretty easy to solve for. To find coterminal angles, just simply add or subtract 360 degrees from the original angle that it provided you with. So if we're going to find the coterminal angle of 30 degrees, how about we start by plotting 30 degrees? Now that we have plotted 30 degrees, how do we find the positive coterminal? Well, we're just going to take 30 degrees and add 360 to it, which would give us 390 degrees. If we're going to draw that, then what we would do is go past the ray and then return back to it. We've just made a 390 degree turn. Now, if we're going to solve for a negative coterminal, that would simply be 30 minus 360 degrees, which would be negative 330 degrees. So what we're going to do is we're going to start at our initial side. We are going to go in a clockwise direction to return back to our ray. We've made a negative 330 degree turn. We're going to plot 167 degrees. 167 is not quite 180, but close. So there's our information in standard position. If we're going to find positive coterminal, just take 167 degrees, add 360 to it, And now what we're going to do is we're going to do a positive 527-degree turn. Start at your initial side. Pass your ray once. And then stop at it. In order to do the negative coterminal of 167 degrees, take 167. Subtract 360 degrees. I'll give you negative 193 degrees. So what we want to do now is make a negative 193 degree turn, starting from our initial side, going in a clockwise direction, which would put us there. In order to do negative 45 degrees, let's first plot that. Negative 45 degrees, starting from our initial side, would be right about there. We now have our array. So here is our information in standard position. If we are going to find the positive coterminal, what you're going to want to do is take negative 45 degrees, add 362. That would give you 315 degrees. So this is, we're finding the positive coterminal. So start at your initial side, go in a positive direction, which is going to be counterclockwise, until you make a 315 degree turn, which would be there. In order to find the negative coterminal, we're going to start with negative 45. Subtract 360 degrees, which would give you negative 405 degrees. So in order to plot that, start at the initial side, go in a clockwise direction. You're going to pass your array once. You have to make a 405 degree turn. Stop there. Now we're going to plot reference angles. A reference angle is the angle between the terminal side and the closest x-axis. Y'all, your reference angles will always be positive and they will always be acute. So if we're going to find the reference angle for 60 degrees, how about we first start with plotting 60 degrees? We could say that's 60 degrees. So once again, the reference angle is the angle between the terminal side, here's our terminal side, and the closest x-axis. So that would be here. So in this case, our reference angle from 60 degrees is 60 degrees. And here's a little cheat sheet that will help you determine, well, how do we determine what our reference angle is? If it's in quadrant 1, if your terminal side is in quadrant 1, then whatever your degree is, that's going to also be your reference angle. If your terminal side is in quadrant 2, then it's going to be 180 degrees minus the amount it gives you. If you're, sorry, I had somebody walk in the room. If it's in quadrant 3, if your terminal side is in quadrant 3, then it's going to be your angle minus 180 degrees. If your terminal side is in quadrant 4, then it will be 360 degrees minus your given degree measurement. All right, so if we're going to plot the terminal side of 120 degrees. Remember, your reference angle is the distance between your terminal side and the closest x-axis. So this is the angle measurement we need here. We would do 180 degrees minus 20. So that would give us 60 degrees again. All right, if we were now going to plot 240 degrees, 240 degree turn. Right about there. Since we are in quadrant 3, in order to find the reference angle, the difference, remember, reference angle is terminal side, and then the distance from the terminal side to the closest x-axis. So in this case, we need this distance here. That would be your theta given the amount, 240 degrees minus 180, and that will give you a reference angle, which is going to be 60 degrees again. I don't like that they gave you examples that all equal out to be 60 degrees because y'all, that's almost never going to be the case. But luckily they provide us with some more examples on side 3. So let's get to those. If we're going to draw 210 degrees, 210 is a little bit more than 180. In order to find the reference angle, we need to find the distance from our terminal side to the closest x-axis. So that would be here. We could find the formula on the previous side. for quadrant 3 reference angles. That would be the measurement minus 180 degrees to find a reference angle here, for a final answer of 30 degrees. If we're going to plot negative 210 degrees, let's go in a clockwise direction. 210 be right about there. There's our terminal side. In order to find the reference angle, we need the distance from our terminal side and the closest x-axis. So that's what we need. We made a negative 210 degree turn, rotation. But let's just pretend it was positive for now. This right here, if we were to stop here, that would be 180 degrees. So 180 plus what would give us 210? 30. Remember, your reference angles are always going to be positive. They're always going to be acute. And lastly, we can plot negative 225 degrees. Here's our terminal side. In order to find the reference angle, we need the terminal side. Compare that to its closest x-axis. So we need to find that distance there. So here, from here to here, is a 180 degree turn. This were a positive amount, 225. 180 plus what would give us 225? That would be 45 degrees. That's how you find reference angles. Memory lane. Labeling sides as opposite, adjacent, or hypotenuse using angle B as your reference points. Here's what we're going to do. We're just going to go back to our trig cheat sheet. So in order to find sine from any reference angle, you would need to do opposite over hypotenuse. Cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. Now remember, these are our reciprocal functions. We did this unit 1 on our review. In order to find the reciprocal of sine, that's cosecant, instead of opposite over hypotenuse, we just flip it. It's actually hypotenuse over opposite. Cosine, its reciprocal is secant, and the reciprocal to A over H, H over A. Tangent, its reciprocal function is cotangent, and the reciprocal of O over A is A over O. Don't worry about this stuff. I'll make sure and talk about that whenever I see you guys again next class.